All right, let's do this. So now we're going to be covering encryption. Encryption is extremely important because, well, quite frankly, it protects our data both rest and in transit. Today's focus is going to be on encryption on an actual system. So data at rest. We're going to start off with working on a Windows system, and then we're going to move on over to Linux and yeah, pretty much those two, Windows and Linux. We might hit up some Mac a little bit later if we got time. No promises though. So I'm just going to share my screen for the Windows virtual machine, which you should have loaded up at this point. And we're going to start off with going to System and Security and enabling BitLocker. Bear with me, the virtual machine can be slow at times. And we're going to be searching for System and Security BitLocker Drive Encryption. And then we're going to turn BitLocker on. We're going to save to a file. Okay. I knew that was going to happen. Happens every time. So, anybody know why you wouldn't be able to save directly to the drive you're about to encrypt your recovery keys? So what we're actually going to do here is we're going to shrink our volume first in disk management, and then we're going to create two partitions. One's going to be where we're going to put our recovery key, and the other one's going to be used later. I'm going to fast forward to the future. So 4096. New simple volume. We're going to go 2048. And then this one here, we're going to go new simple volume. And there we go. We got two new partitions. Now we can close out our disk management. And let's turn on BitLocker. Then we're going to save our recovery keys. Save to a file. Oops, not downloads. Backup. Since it's not registering as a removable drive, well, it's still not going to work. So we're just going to print a PDF and just print it to our backup. So you're going to have two options here. One will encrypt the entire drive. The other one will only encrypt the space that's being used. We're just going to go with the defaults and then start encryption. We did have a removable drive attached or available in the virtual machine. We can also use BitLocker to go to encrypt that drive. Now we're going to use VeraCrypt. So we got to install that first. VeraCrypt is a freely available encryption software that you can use to do similar stuff as BitLocker. So let's open up our VeraCrypt. And what we should do is, since we're going to be encrypting the backup, we're going to take our PDF for the recovery key and we're just going to move it over to our documents for now. Doesn't really matter because we don't care too much about it, but just for sanity's sake, that's what we're going to do. And while we're going through all that, we're just going to explain a few things. So encryption is a process of converting data, so plain text, into unreadable ciphertext using algorithms and keys. This ensures sensitive information remains confidential from unauthorized access. Decryption back into so encryption across multiple Windows, Linux, Mac OS, and it's to protect data on the disks and in transit networks. Each of these OSs has a built-in tools for securing data through encryption, and each may also benefit from additional software. It's more complex. So encryption on Windows. You can use BitLocker, which is a full disk encryption feature available in Windows 10 Pro and Enterprise and higher versions. It encrypts the entire disk, protecting data at rest, supports the Trusted Platform Module or TPM for secure key storage. Encrypting file systems, or EFS, is a file system level encryption option for individual file holders on an NTFS file system. It allows users to store encrypted data without encrypting the entire drive, and different users can have different encryption keys. Okay, well, that's done. So before we go any further, I just want to play with a couple more things, and then we're going to continue on with using Verify. So let's just create a new folder. Within that new folder, let's create a new text file. Then let's move back over to the folder, right click, go to our properties, let's go to advanced, and you can encrypt it. There we go. We just use EFS to encrypt that folder, so only this user can access it. Now let's go back to Vericrypt, where we're actually to get our encryption done. I'm just going to go standard. There we go. Let's go back up. Encrypt the volume and format it. We can pick one, many encryption algorithms. Let's test our AES. Self-test all algorithms. There we go. We'll use a SHA-512 hash algorithm. Now let's set our password. There we go. Now let's format. You're going to get a lot of prompts throughout this process. And there we go, successfully created. Now we can exit out of there. Ah, no. Okay, so what we're going to do is we're going to select a free drive letter, and we're just going to click auto mount. Type in the password, and then click OK. It'll take a hot minute, so we'll skip forward. So now that it's mounted, as you can see here, mounted 2 gigabytes, AES normal, and it's accessible under local disk Y. So we're just going to exit now. Close out of that. And then we're going to open up PowerShell or terminal, and we're going to run it as administrator. Okay, so now that we have PowerShell opened as an administrator, let's encrypt some data. So data equals sensitive data, and then encrypted equals convert to secure string data as plain text force, and then encrypted convert from secure string out file encrypted txt. There we go, save to file. Let's open up Notepad, encrypted.txt. Give it a hot second and it should open up. And there we go. There's the encrypted string. We're just going to close out of there. RM encrypted.txt. Let's clear. And then we're going to open up CMD or command prompt as admin as well. Oh, yes, we want to create the new file. Hide me. Save. Let's close that. Once it's closed, we're going to type in cipher e hide me.txt. Was encrypted. So let's go notepad.exe again and hide me.txt. Plain text ciphertext may leave old plain text on disk volumes. It's recommended to use the command cipher. Clean up the disk after converting is done. Okay, let's just go cipher. It'll let us. Cipher d hide me.txt. And there we go. It's been decrypted. Let's clear our screen. And continue on. So the next thing we got to do is we got to open up the Ubuntu workstation. So we're just going to shut this bad boy down, so we're not using too many system resources all at once. And we'll fast forward to the future. Okay, so now we got Ubuntu open. And we've got some stuff we're going to have to do. So start off with opening up our terminal. Excuse me. So let's go sudo apt install crypt setup. And enter your password. Yep. We want to use up that disk space. Yeah, once that's installed, we're going to use DD to create a 100 megabyte file called encrypted.img. This will serve as your encrypted container to store that directory, or to store a directory. So we're going to use a command, which is if equals dev0, which will fill with zeros, of equals encrypted.img is the output file, bs equals 1 is the block size of 1 megabyte, and the count of 100 creates a 100 megabyte file. And then we're going to set up the encrypted container using LUKS. So we're going to initialize a LUKS encryption on the container. Okay, enough talking. Now that we're here, let's start up. So let's go dd if equals dev0 of equals encrypted.img bs equals 1m count 100. Count equals 100. Assuming I typed in everything. Whoops. I didn't type everything in correctly. There we go. Now that is correct. So the next thing we got to do again is the LUKS. So let's go sudo crypt setup LUKS format encrypted.img. Ooh. Okay. Let's just try that again. What is the full message? I know what I did wrong. It's supposed to be a capital F. Don't forget your password. And it's super important to make sure you know what you're doing here. So I'm just going to go over while that's doing its thing. It's already done, so I'm still going to go over right now anyways. So Linux does offer various flexible encryption tools for both data at rest and in transit. So there's LUKS, which is Linux Unified Key Set, which is a widely used encryption standard for full disk encryption. Tools like Crypt Setup work with LUKS to encrypt and decrypt entire partitions, providing good protection for data at rest. You also have dmcrypt, which is a kernel-level disk encryption system that LUKS is often based on. It offers robust encryption for partitions and can work in combination with tools like LVM, Logical Volume Manager. You also have GNUPG or GPG, which is a tool for encrypting files using public key cryptography. It is used for encrypting emails, files, and much more. You have your secure shell or SSH, which provides end-to-end encryption for data in transit during remote sessions, protecting administrator logins and file transfers. And then obviously for everything else, you got SSL and TLS, which are protocols used to encrypt network traffic. These are essential for your HTTPS, ensuring that data is transmitted between web clients and servers, and that it's secure. So now that we got that out of the way, we'll continue on with this exercise. So now we actually want to open it up. So we're going to unlock the container and map it to dev mapper encrypted. So we're going to use sudo crypt setup lux open, make sure that that's capital, encrypted .img encrypted, and then put in your passphrase. Wonderful. Now let's format that container. So mkfs.ext4 dev mapper encrypted. Wonderful. So now you can see we've got that encrypted volume, which is 88 megabytes now. But let's make a mount point. So mkdir mnt encrypted. Perfect. Now let's go ahead with sudo mount dev mapper encrypted mnt encrypted. Perfect. And now, after we're done using that encrypted directory, we can unmount it. But first, let's take a gander. So now let's unmount it. So sudo unmount mnt encrypted. Oops. Perfect. Sudo crypt setup lux close encrypted. So let's see if GPG is working on here. Perfect. Yes, it is. Always got to double check. So now we're going to, let's just touch my file name. Let's just go GPG C file name. Okay, let's touch file name and run that again. So put in your passphrase. Take it anyways. What do we got going on here? File name.gpg. Now, if we want to decrypt it, we just go GPG, file name.gpg. Yes. And there we go. So just to summarize everything going on there. So we got our Lux encryption using crypt setup. This is a widely used encryption standard for encrypting entire disk partitions or disk images. It works at the block level, meaning that any data written to the container is encrypted before being written to the disk. And we got GNU PG or GPG encryption. GPG allows for file level encryption using symmetric encryption, so password based, or public key encryption. It is extremely powerful for protecting your sensitive files. We're going to skip over this one. We're not going to do any practical on it, but we also have our encryption on Mac OS, where we have File Vault, which is a full disk encryption tool that helps protect data at rest. It uses XTS AES 128 encryption with the 256-bit key provided for protecting the hard drive and integrates well with the Mac OS user experience. We've got Keychain, which protects all sensitive information like passwords and certificates on the system by storing these securely and encrypting them using industry standard encryption. We also have SSL TLS, which macOS uses for encrypting our web traffic. Before I move over to the server, we'll actually get that started right now. So I'm going to stop my screen share, shut down Ubuntu. Then I'm going to start up our Windows server. And while the Windows server is starting up, we're going to cover a little bit more on encryption. So we've got our types of encryption, which includes symmetric encryption. In symmetric encryption, the same key is used for encrypting and decrypting data. This type of encryption is fast and efficient, but it does require that both the sender and the recipient securely share the encryption key. So AES, Advanced Encryption Standard, is one of the most secure and widely used symmetric encryption standards. AES comes in key sizes of 128, 192, and 256 bits. It is used in many systems like Lux, BitLocker, and FileVault. DES and 3DES, which is Data Encryption Standard or triple DES, is an older encryption standard. 3DES is more secure but less efficient than AES, and it has largely been replaced by AES. We also have asymmetric encryption. So this is public key cryptography. Asymmetric encryption does rely on a pair of keys, one public and one private. The public key is used to encrypt, and only the private key can decrypt that data. It is used mainly to share keys for symmetric encryption or to ensure the authenticity and integrity of communications. RSA is a widely used public key encryption algorithm, often used for securing transmissions and digital signatures. RSA encryption is resource intensive, so it often is used to encrypt small data or symmetric keys. You also have your ECC or elliptic key cryptography, which is a newer form of asymmetric encryption that offers comparable security to RSA, but with smaller key lengths, making it faster and more efficient. You have Diffie-Hellman, which is used for key exchange, not encryption directly. It allows parties to securely share asymmetric key encryption over an unsecure connection, a symmetric encryption key. Sorry about that, guys. You also have your hybrid. So hybrid encryption combines both symmetric and asymmetric encryption, a commonly used method for encrypting large amounts of data using symmetric encryption due to its speed, and using asymmetric encryption for the secure key exchange. So TLS and SSL are hybrid encryption. They use it to secure data in transit or communications over network, particularly for HTTPS. Asymmetric encryption secures the initial handshake and key exchange, while symmetric encryption is used for the bulk of data transfer. You also have your hashing and hashing with assault. So hashing is not technically an encryption method, as it hashes can't be decrypted. Hashing algorithms generate unique hashes from data inputs. Hashes are used for password storage, digital signatures, or verifying integrity of files. A salt is an additional random value added to the input data to strengthen that hash. So SHA-256, which is a secure hash algorithm at 256 bits, is commonly used for verifying data integrity in blockchain, password hashing, and so on. MD5 was once a commonly used one, but it's now considered insecure due to vulnerabilities and is pretty much deprecated. We're going to finish off before we get to the server by let me just log into it. I'm hoping I remembered the password. Yeah, we'll find out momentarily, but we're going to go over encryption in transit. I can always just reset the password later. Encryption in transit refers to protecting data as it moves over a network between systems or between devices, ensuring that the data cannot be intercepted or tampered with by attackers. Some of the examples would be like TLS and SSL, which encrypts browser to server communication, SSH encrypting your terminal and command line sessions, IPsec VPN, which encrypts data sent between locations over the internet. That encryption, sensitive information like login credentials, payment data, and personal information can be intercepted by attackers through techniques like man-in-the-middle attacks or MITM. Encryption at rest, that applies to anything stored on disks, databases, cloud storage devices, and so on. You got your full disk encryption and file system encryption and other means of encryption as well. So let me sort out this password situation. We'll get back to it. Okay, so now that I have the password situation resolved, we're going to install SQL Server, the developer edition, and simply look it up and download it from the Microsoft website. And then we're going to install, once it's done downloading, the SQL Server Management Studio. So just double click on the installation file for SQL Server. And then we're going to go from there. This could take a little while, so just be patient. We're going to go with default installation, so it might take a while, depending on how fast your internet connection is and how many resources you allocated for Windows Server. Okay, so now it's installed. Let's get SSMS. So we're just going to close. And install SSMS. In order to continue installing the management studio, we've got to restart the PC. So go on, restart, and I'm going to fast forward. Now that we've restarted, let's give this a shot. So just double click on your setup and wait for it to load up. While it does that, I'm going to simply fast forward. Or not. It's already up. There we go. Again, we're going to go with the defaults. Professor, and well, we're done installing the management studio. So let's close that bad boy up. Let's hope the virtual machine's responsive. There we go. We're finally on our way. Might be time to time travel again. Time traveling complete. Ooh. You get that error, just make sure you trust it. Like force, make it mandatory. So just make sure you create a new query. Go use master. Go create master key encryption by password equals I am strong, or your strong password. Then go. Let's try to run this and see if everything works the way we want it to. Ooh, commands completed successfully. So what that did is the master key encrypts the server certificate. This command will create a master key, which is encrypted by the specific password. The next thing we're going to do is we're going to create a server certificate. So the server certificate is needed for encrypting the database. So now we'll go create certificate my server cert. Whoops. Unintended semicolon with subject equals my server certificate. And then go. And assuming everything's typed correctly, we didn't miss anything, this should work. Commands completed successfully. Wonderful. Now well, first we need to create a database. So let's go new database, and we're going to call it my database. Whenever it decides it wants to load my database. Add. Perfect. Let's go. Okay. No, the file name was empty. That should work. There we go. My database. Tables. Anyways, let's do this. Use my database. Go create database encryption key with algorithm equals AES underscore 256. Make sure numlock's enabled if you're using it. Encryption by server certificate my server cert. Go. Assuming we did everything correctly, we should be able to just execute that. Warning, certificate used for encrypting the database encryption key has not been backed up. You should immediately yada yada yada. Yes, always back it up. So this creates a database encryption key for the selected database using AES 256 encryption. So now what we're going to do is we're going to alter the database to enable encryption for the database. We're going to turn on encryption for it. So alter database, my database, set encryption on, go. We'll see if we have any typos. Let's go execute. Perfect. So now let's go back up database, my database to disk equals C backups my database dot back, close it off, semicolon, go. Now let's hope that works. Ooh. Okay, we haven't actually created the directory for that. So we're just going to save it to C. Let's go again. Really? That's permissions error. It really doesn't like that we were trying to save it there. So let's go backups. Give that a shot again. Perfect. Now we can restore it. So restore database, my database from disk equals C backups my database dot back, and then let's go. Oh, it's being used in the session, so we can't actually use it right now. It's supposed to restore the database from the backup. Since TDE is enabled, the restored database will remain encrypted. Now, just assuming that you have more than one database in there, all we're going to do is we're going to use other database to deselect. Or not, what's going on here? What's its deal? Why can't it locate it? Yeah, that's what I thought. Screw it. Cancel. Let's not save. Let's go new quarry. Go through this again. So we're going to use our database. Let's back it up again. There we go. We successfully backed up the database. Let's see if we can do this with the new quarry without erroring out this time. Well, anyways, so what we'll do here, give it a shot. Other database. New quarry. Okay, so back to what I was going on about before we erred out again there. So the master key and server certificate are crucial for decrypting and accessing the encrypted data. So make sure you back up the master key and certificate for disaster recovery. Let's take a look at this. Cannot be obtained because the database is in use. Good to go. No. Okay, so one more time we're going to try it this way. Doesn't work. Try another way. If the easy way doesn't work, we'll try the hard way. Figured. All right, so what we're going to do is we're going to go through the backup script again, and then we're going to try this one. Yeah. Okay, so this error that we're encountering is that it has not been backed up, which indicates that the server is requesting a log backup before restoring the database. So for us to resolve this, we can back up the transaction log with no recovery option, then proceed with the restore. So what we'll do here is let's hope this works. And there we go. So I'm just going to go over everything that we did there. So originally, we had a backup script, which you would assume would work. So backup database, my database to the disk in a directory. As long as we create the directory, should back up there. And it did. We're having issues with the restore because, well, quite frankly, we were accessing the database while trying to restore it, which caused issues. So we tried to pivot by switching which database we're actively using. Didn't exactly work the way we wanted it to. So finally, what we're doing here is before restoring our database, so backed up just fine, but before restoring the database, we were required to back up the transaction log. So we backed up the transaction log with the no recovery option, which leaves the database in a restoring state, allowing us to restore a full backup afterwards. This ensures that no active transactions are lost before performing the restore. Now that the log had been backed up, we can proceed with the restoring option. So then we went through that. So the with replace option is used to overwrite the existing database with the backup. We then set the database into multi-user mode. So once the restored operation was complete, we set the database back into multi-user mode so it can be accessed by other users. So that's it. We've done our encryptions and we've done our encryption and we've done our backups. We are now good to go. See you guys in class.